Okay, guys, we're continuing on to the problems. Now, we already did one as an example. Now, number two. And we're going to do part A, find the distance, and part B, find the midpoint. And this, this is going to become routine. My recommendation, one more time, try all the questions right before I show you the answer. So pause the video as much as you need to, try the question out, and then, then make sure that you did it correctly. Or if you're not sure what's going on, then you can watch another one as an example. Okay, so part A, we're finding the distance. The distance, I'm going to use the shorthand notation this time. The distance, that's ugly D. The distance is equal to the square root of, if you want to, you can write this part in just as a reminder. X minus x1 squared plus y2 minus, y1 minus y2 squared. Oh, by the way, though, if you do switch it and say y2 minus y1, you get the same result. So it's not such a travesty to do that. Okay, but let's keep it consistent with the formula, what it said. Is this going to clean it up? No, it's not. Okay, so x1 was -3 in this case. I'm looking at problem number 2, yeah? So -3 minus 9 square it plus -2 minus 3 square it. And you can use a calculator for these parts if you're not comfortable with the arithmetic, but -3 minus minus 9 is -12 square it plus -5 square it. Oh, this is a nice example. This is one of the known perfect triangles. It's going to be 144 plus 25, which is the square root of 144 plus 25 is 169. Square root of 169 turns out to be exactly 13. So the distance is 13. Notice distance is always going to be a positive value because you can't have a negative distance. Distance is a measurement of how long something is. Okay, part B, the midpoint. What were my points again? I'm just going to... Oh, you know what I do? Let me see. I'm going to see if I can copy this thing. Copy. And paste. Okay, so these are my coordinates. It's number 2. Okay, so... let's do the midpoint with red. Midpoint is a coordinate. The average of the x values, -3 plus 9 divided by 2. And then the average of the y values, -2 plus 3, also divided by 2. Oh. Okay. -3 plus 9 is, what is that? 6. You think I'd be faster as a math teacher, yeah? 6 divided by 2 is 3. -2 plus 3 is 1. So 1 divided by 2 is 1/2. There it is. Problem 2 done. Sweet. Okay, on to problem 3. Let's do the next page. Okay, problem 3. Same thing. Let's do distance first, and we'll use the darker color for distance. Distance is the square root of, we'll skip the formula and just go straight to the actual numbers now. -1 minus -1, that whole thing squared, plus 1 minus, I'm sorry, I read that wrong, guys. I read that wrong. Back up a little bit. So -1, the first one, x coordinate is actually this whole thing. So -1 minus -1 plus 3 square root of 3. That whole thing squared. And then plus 1 minus 4, that whole thing squared. Okay, so this one's like looking like it's gonna be a little cumbersome, but something nice happens to at least make our lives slightly easier. When I go to the next point, I have to finish the subtraction before I square, right? Well, I have -1 minus -1, and minus -1 actually cancels out. So these guys cancel each other out. And that leaves me with -3 root 3 squared, inside the square root, plus 1 minus 4 is -3, still squared, yeah? So that's nice. Now, when I square something like this, I've got a regular component and a root component. I just square them both. So negative 3 squared will be 9. Sorry, this is all inside the square root. Negative 3 squared is 9. And then the square root of 3 squared is just 3. So it's 9 times 3. Plus negative 3 squared is going to be 9. Right? So 9 times 3 plus 9. I'm just alternating so we don't confuse the lines. 9 times 3 is 27. And 9 is just 9. So 27 plus 9, which is the square root of 36. 27 plus 9 is 36. Which, oh, nice. That's just 6. Beautiful. Okay. So that's part A. Part B, so this is part A. Part B is the midpoint. So midpoint is halfway point of those two numbers. -1 plus -1 plus 3 root 3 all over 2. It's a good practice just to keep that second number in parentheses so you don't mix them up. And then the next number is 1 plus 4 divided by 2. Okay, let's do just a tiny bit of simplification here. So m is going to be -1 plus -1 is -2 plus 3 square root of 3 all over 2. Plus 1 plus 4 is 5 over 2. Oops, I'm sorry. This is a comma, not a plus. 1 plus 4 is 5 over 2. 1 plus 4 is 5, and then divide by 2 is 5 over 2. Okay, that looks pretty much it. I'm okay with this format. Some people would like to maybe separate these two parts. That's okay. -2 divided by 2 would be -1. And then you still have this part as being 3 root 3 over 2. And the right side would still be 5 halves either way. Now, in terms of which one do you think is more simplified? Honestly, I think they're both roughly the same level of simplification. So I would, on an exam, I accept either one of these. This one or this step is still okay to me too. Well, this highlighting is not looking good. Okay. All right, that was question number 3. This video, I'm gonna do numbers 3 through 7. Numbers 2 through 7. I mean. So the next one is number 4. We've got 1, 2, 3, 4 more to go. Number 7 is actually gonna be quick though. Oh, number 4 should be easy too. Okay, number 4 is easy. Where you have letters, yeah? Okay, maybe not so easy as I thought. Okay, let's try it. So distance is the square root of the x component subtracted and then squared, right? So that's going to be m minus, be careful here, minus a -n and then squared, right? And then the difference of the y coordinates. So that's going to be n minus -m squared. This is just straight application of that formula. Okay, what does that give us? Okay, well, let's do a little simplification before we square. I forgot, I wanted to alternate colors when I'm doing this blue one because it's easier to see this way. That's going to be m plus n squared, right? And then plus, this is n plus m squared. Oh, okay. That's cool. So now these are going to look very similar. What's m plus n squared? So, you foil the thing out. If you're not sure how it's going to turn out, you can actually do this whole process. Just write it twice, and then you do first, and then the outers, and then the inner, and then the last, right? We call that foil in America. I know not everyone grew up learning math in America, so just that's the acronym comes from. But also, when you have binomials, this is called a binomial when you have two terms, and then you square it. It's got this form, it always comes out the same way. Where you square the first thing, square the last thing, and in between you have double the product of the middle one. So 2 times mn. It always turns out that way. So that's the first one. And then the second one, look at it. It's the same thing, right? So I'm going to get the same exact result. Of course, technically speaking, the n would come first, but it's the same thing because n plus m same as m plus n. That sounds like almost n plus m is same as m plus n, right? So I have the same exact thing. 2mn n squared, that whole deal. Okay, now let's combine things that are the same. I got 2m squareds here. So I've got 2m squareds. Here I have 2mn 2 times, that's going to give me 4mn. And then I've got n squared 2 times. So that's going to give me 2n squared. All right. Let's see. Is there anything that's going to simplify? I'm going to get 2 times m plus n squared. Oh, you know, I just realized. I probably did this, I did this in the inefficient route. Okay, I did this very inefficiently. Because what's going to happen? This is going to, if I factor out a 2, I'm going to get 2 times m squared plus 2mn plus n squared, right? Okay, I'm being silly, guys. I'm being silly. Okay, I'll just follow this through so you see what happens, but then I'll show you how I should have done this. Okay, so I'm going to get the square root of 2, and then m squared plus 2mn plus n squared. That's just m plus n squared, right? But when you have something squared, you got something square rooted, you can just take their square root and dump that square, right? So that's going to actually be the square root of 2 times just m plus n. Now, it's technically speaking, because I square rooted a square, it's actually the absolute value of m plus n. Why is it the absolute value? Okay, that's kind of a weird phenomenon, but when you square something, it forces it to be positive, right? And then when we square root it afterwards, it takes the original number, but it's just positive. So it's square root of 2 times the absolute value of m plus n. Now, why was I being silly? I'll tell you why I was being silly, because I could have cut out all of this extra work. I did that really for nothing. So I should have just ignored all that, because look, m plus n squared plus n plus m squared, that should have taken me directly to 2 m plus n squared, right? That would have been the much more efficient route. But it's kind of good. I'm going to leave this mistake in here because it's not really technically a mistake. It's just I took a longer route. And that happens sometimes in math, where we took a route, we go around the bush, we take a detour that we didn't need to, but in the end you get the same result. And that's okay. Just because it wasn't the most efficient way, it doesn't make it wrong. Sometimes that happens when we're doing like a test too, right? Okay, let's do the second part. Second part is to find the midpoint. I've got mn, let's zoom out a little bit, and negative n, negative m. This part should be easier, I think. M plus negative n divided by 2. Next one is n minus, or n plus negative m divided by 2. And I'm pretty much done. I'm pretty much done. It's going to be m minus n over 2. This one is negative m plus n. I'm just listing them alphabetically. That's why I switched the order there. But same thing. If you left it as n minus m, I wouldn't mark you down. There's the answer there. And the distance was over here. This was the distance. Okay, sweet. 5, 6, 7. I got 3 more to do. 3 more to do. Number 5. 6 and 7. Here's 5. Okay, in its own page. And we'll start with blue. Okay, so distance. Oh, okay, I see it's going to happen already. I've got a difference of squares. That's nice. That is beautiful. Let's see it. The distance is the square root of that first guy, v minus w, minus the second guy, v plus w. That whole thing squared. Yeah. Oh, okay. Actually, no, not a difference of squares, but it's gonna be nice. You'll see. And then plus the second one. They're both the same position of t. They're both t. It's gonna be t minus t squared. If you think about this, if the second value is both t, just think with me visually for a second. That means your 2 points, they got the same t value. They're in a straight line, right? It's just gonna be the difference between the x values. That means. Okay, but let's continue on anyway. Okay. So this first one, check this out. You got v minus v, right? That's gonna be 0. And then you got negative w minus W. So that is 0 as well. Wait, what? That means the distance between these two that guys is gonna end up being 0. Okay, let me write out this so you can see it. So this is gonna be V minus V, right? No, I'm sorry, guys. Let me write it out one at a time. So V minus W. That's the left side. And then this minus applied to the V is going to give me minus a V. Minus applied to W is a minus W. Oh, okay, I'm sorry. It wasn't. I had it mixed up. This is actually minus W. So good thing I took the time to write that out. And then squared, yeah. Plus T minus T is 0, so 0 squared. Okay, there we go. So now the V minus the V cancels each other out. Negative W minus W is negative 2W. And remember, that's squared. Plus 0, but that 0 is just going to disappear. So no sense writing it. Okay, next line. Negative 2W squared. When you square something like this, remember you square the number. So that gives me 4. And you also square the letter. So that gives me W squared. All right. What is that? It's going to be 2W. But note here, W for W bigger than 0. So, or if you want to, you can just say this is absolute value of W. Okay, so basically 2W, as long as W is bigger than 0. And it has to be because we're talking about distance, right? Distance got to be positive. So to me, actually, it makes more sense to just say 2W where W is positive. Or at least non-negative. I keep going back and forth. I think absolute value is actually, let's keep absolute value. That was the answer. Yeah, done. Okay, next part. That was part A, now part B. Part B is to do the midpoint, right? What's midpoint? So midpoint is V minus W plus V plus W. Now, quick tip, let's keep our numbers in parentheses so we don't get mixed up. Divide by 2. Second part is T plus T, sorry. Divided by 2. T plus T divided by 2 is 2T divided by 2. This is going to be back to T, which I should have suspected. Okay, M. V plus V is 2V. Negative W plus W is 0. So 2W divided by 2. And 2T divided by 2, like I said, is just T. But let's take the time to write it out because I did for the first number anyway. So that's W comma T. Huh. Interesting. W comma T. That's the midpoint. Okay. That's number 5. Whew. So the video's going longer than I thought. Okay, number 2 more. 6 and 7, but like I said, 7 is going to be easy. 7 is going to be easy. So that's the last thing I can at least look forward to. Here we got pi. Don't be intimidated when you see pi, guys. It's going to be okay. It's just a number. It's just a number. Approach it the exact same way. What's the distance? It's the x values subtracted by each other. And then squared. Plus the y values subtracted by each other and then squared. This looks like to be maybe the easiest one so far. What's pi minus pi over 2? Pi over 2. And then square it. What's 0 minus 1? Negative 1. And then square it. Adding the 2 together. Okay, what's pi over 2 squared? That's pi squared over 4. What's negative 1 squared? 1. 1. So it's pretty much that. Square root of pi squared over 4 plus 1. Okay, let me think. Is there a way to simplify this? You know, there's a little simplification that you could do, I guess. You could treat 1 as 4 over 4. and then add them together. So you'd have pi squared plus 4 over 4. Or another way to think about that is that's 1/4. The square root of 1/4 times pi squared plus 4, right? And 1/4 is one of those perfect squares. So you can pull that out because 1/2 times a half is a fourth. So I could change it to 1/2 the square root of pi squared plus 4. So I guess that's a little nicer. Yeah, you know, if you stop at this point, I'm okay with that. This would be, I think, the full simplified version. Okay, let's move on to midpoint. Midpoint between pi 0 and pi over 2, 1. Add them together. Divide by 2, right? That's the x coordinates. And then add them together. Divide by 2. That's the y coordinates. So what do I get? Pi plus pi over 2 is 3 pi over 2. And then divide by 2. This is 1 over 2. When you have 3 pi over 2 divided by 2, you're just doubling the denominator. Okay. I think this confuses people. So let me just write that for a second. So I have 3 pi over 2 divided by 2, right? When you divide by a number, the same as multiplying by its reciprocal, right? So now if I was to multiply these things out, 3 pi is on the top, 2 times 2 is 4. So that's what I was trying to say. It's like the same thing as doubling the denominator here in this instance. So you have 3 pi over 4 is the result, and 1/2. Oh, I'm sorry, guys. I wrote a plus again. That was supposed to be a comma. So 3 pi over 4, comma 1/2. And that's the midpoint. Whew, okay. Almost there with this video, guys. We're almost done. Last one. Take a look again at the distance and midpoint formulas. What if we had 3D points? What do you think the distance and midpoint formula would be for x1, y1, z1, and x2, y2, z2? For this one, I'm going to do it inside of the formula boxes. Okay, so this is problem number 7 here in red. So the distance between x1 and y2 is x1 minus x2, y1 minus y2, and square them both, right? So if I add a third component, z1, z2, what do you think is going to happen? Well, I would just extend this, right? z1 minus z2, square that. And that's the only difference. Oh, those z's look terrible. Let me write that again. By the way, you know, when I write my z's, I write a line in between. That's just to distinguish them from like a 2. z1 minus z2 squared. So here's the overall distance formula, and I'll do it the shorthand way, just d. Starts out the same, right? x1, I'm just copying down what I just wrote. x1 minus x2 squared, y1 minus y2 squared, z1 minus z2 squared. And that's the new distance formula for 3 dimensions. If you had a 4th dimension, you do the same thing, same pattern. You just add the new component at the end, and it would still work. Okay, what about midpoints? Well, here's 1 dimension, take the average of the x's. 2 dimensions, take the average of the x's and the average of the y's. So for 3 dimensions, if I have x1, y1, z1, x2, y2, z2, the midpoint would be the average of the x's, comma, the average of the y's, y, and then the average of the z's. And that pattern would continue. Even if you have 4 dimensions, same idea. But this is the answer for 3 dimensions. So that's problem number 7. Okay, guys, finally, we're done with the questions 1 through 7. So I'm going to stop this video. The next one will address the last 2 applications and their problems.